Okay, so we're going to talk about Target 2 in Unit 3, and that is solving algebraic equations involving angle relationships. Before we get into that, though, we need to discuss how to determine what a transversal line is with respect to any two lines. What we learned in the first target is that a transversal line is a line that intersects two other lines at different points. So if you look at the example on the left-hand side, it's pretty easy to see that line B is going to be the transversal line because it is intersecting two other lines at different points. It's intersecting A at this point, and it's intersecting C at this point. So B is the transversal line intersecting A and C. The example on the right-hand side is a little more difficult to see. You got a lot of possibilities for transversal lines. Let's start off with E. Does line E intersect two other lines at different points? Yeah. E intersects line D and line F at this point and this point. Is E a transversal line to anything else? Does it intersect any other lines? I would say the answer to that is no. So E is only a transversal in one case in that diagram. Is D a transversal line? So if you look in the diagram, does D intersect two lines at different points? So here's D. I believe it intersects E, and it intersects F. So D would be a transversal to E and F. But also, is D a transversal line to E and G? D is intersecting E at this point, and it's intersecting G at this point. So you could say that D is a transversal line to both E and F, but then it's also transversal to E and G. Is it fair to say D is a transversal to F and G? So here's D. It's intersecting F at this point, but it's also intersecting G at the same point. So I would say that D is not going to be a transversal to F and G just because it's not intersecting F and G at different points. Any other transversal lines here other than E and D? Well, let's look at G. Does G intersect two lines at different points? So here's G. G does intersect two lines. It intersects D and F, but it intersects D and F at the same point. So G cannot be a transversal line. The last line we need to look at is F. F is a transversal. It intersects E at this point and D at this point. So F is a transversal to E and D. But F is also a transversal to E, intersecting at this point, and G, it intersects at that point. F is intersecting G and E at those 2 points. So F is a transversal to E and G. Is F a transversal to G and D? So here's line F. It intersects G at this point, and then it also intersects D at the same point. However, since F is intersecting G and D at the same point, it won't be a transversal to those two lines. So these are the 5 possibilities that we have here. Okay, now we talked about corresponding angles and alternate interior, alternate exterior, same side interior in the first target. In the second target, we're going to talk about how those angles compare to each other when we have parallel lines. 1 and 5 are corresponding angles. If we have parallel lines, then corresponding angles are congruent. Now, this can be written as a biconditional, which basically means if we have parallel lines, then corresponding angles are congruent. But let's just say we didn't know these lines are parallel. Let's say originally I came in, I told you, I said, listen, 1 and 5, angle 1 and 5 are congruent. And you tell yourself, well, listen, those are corresponding angles. Angle 1 and angle 5 are corresponding angles. Remember, corresponding angles, they have to be on the same side of the transversal. and one inside the two lines and one outside the two lines. If I said those two angles are congruent, then you could determine that the lines are parallel. So if you know one, you know the other. That's the biconditional statement. So if two lines are parallel, corresponding angles are congruent. Okay, what must x be to make these two lines parallel? I don't know if they're parallel, but I want to make sure I can prove that they are. Well, the only way these two lines would be parallel is if these two angles would be congruent, because those are in corresponding positions. So I'd set them equal and solve for x. And you'd get 15x equals 60. X is 4. If x is 4, then that means if I plug 4 back in for x, 15 times 4 is 60, plus 15 is 75 degrees. If x is 4, that means this angle is 75. This angle is also 75. And because those two angles are in corresponding positions and they're congruent, that means the lines have to be parallel. So x being 4 is what makes those parallel. All right, so if we have parallel lines, we already know that corresponding angles are congruent. Corresponding angles would be this angle and this angle. What's the relationship with alternate interior angles? Well, here's this angle here is alternate interior to this angle. Well, if the lines are parallel, then those have to be congruent. Alternate exterior, same thing. Angle 2 and angle 7 are alternate exterior. And if I tell you those lines are parallel, then that means that those angles are congruent. Now, angle 2 and angle 7 are congruent to each other, but I'm going to fill this in. I'm going to put 1, 3, 4 here. I have 7, I'm going to put 6 here. I'm going to put 5 here and 8 here. Okay, so I told you those lines are parallel. So yeah, 7 and 2 are congruent because they're alternate exterior angles. 1 and 8 are congruent because they are alternate exterior angles. 4 and 6 are congruent because they are alternate interior angles. 3 and 5 are congruent because they're alternate interior angles. But is 6 and 3 congruent? No. 6 and 3 would not be congruent. They are not alternate interior angles. Okay, corresponding angles are congruent. That would be 2 and 5. 8 and 4, 1 and 6, 3 and 7. In fact, with those 8 angles, we have 4 of those 8 angles must be congruent to each other, and the other 4 must be congruent to each other. Do you know which 4? 2 is congruent to 3. 3 is congruent to 7. 7 is congruent to 5. 5 is congruent to 2. So basically 2, 3, 5, 7 are all congruent to each other based on any combination, any combination of your angle relationships, corresponding angles, vertical angles. 7 and 5 are vertical. 7 and 3 are corresponding. 2 and 7 are alternate exterior. 3 and 5 are alternate interior. So those 4 angles are congruent. The other 4 are also congruent to each other. So that would be 1, 4, 6, and 8, all for the same reason. Okay, the last relationship we're going to discuss is consecutive interior, or same side interior. 4 and 6, same side interior. And those would be supplementary. So if we know that, let's figure out what we have going on here. We have two lines that are parallel. We have two angles that are same side interior. We just learned that same side interior angles must be supplementary if the lines are parallel. So these two angles are supplementary. We'll just add them together and set them equal to 180. So I'm adding this to this. 5x plus 5x is 10x. Negative 7 is negative 14. Solve it for x. X equals 19.4. So that would be your answer. Now I want to investigate this a little further. What I want to do is take 19.4 and I want to plug it in for x to find out what I'm going to get here. 5 times 19.4 is 97. And minus 7 equals 90. So this is 90 degrees right here. Do you notice that both of these angles have to be the same because they're both 5x minus 7? So I guess this would also mean that this is 90 degrees. Does that make sense that they'd both be the same? It should. If they both equal each other, if they're both 5x minus 7, then they both have to be the same angle, right? And if those are both same side interior angles, that means they have to add up to 180. Can you tell me two angles that add up to 180 that are the same? That'd be 90 and 90. So you could have determined what each angle was prior to solving for x. And that completes target 2.